Okay, here are a couple of simple demonstrations of analog gauges. Analog gauges are the primary application of what happens when you have a loop of wire, you pass an electrical current through it, and you then have that loop of wire in the presence of a magnetic field such that a torque is exerted upon that loop of wire. Okay, this right here is a demonstration galvanometer. The amount of current that would cause the galvanometer's needle to swing to one side or the other is actually very small. Okay, now let me show you here kind of in close-up. Okay, right there you see a coil of wire, and that is then attached to the needle like so. And then off to the side here and here, this casing that you see is the permanent magnet. And then right over here is a resistor and the leads then for the wires that I would use to then turn this into either a voltmeter or turn it into an ammeter. So with a small amount of current that is passing through the wire here, that would then cause a full-scale deflection of the needle to one side or the other. And I'm not going to use this for any of the demonstrations. Instead, let me first of all switch to this multimeter here that you have seen before. That's, by the way, what this is officially called. We can turn this multimeter, for example, into either a voltmeter or an ammeter by manipulating various resistors. So right now I have the dial here switched to the upper left-hand side, where that's now going to mean that the multimeter is going to be a voltmeter. And then when the full-scale deflection current passes through the galvanometer, the needle would swing all the way over to the right-hand side. And then the resistor that is placed in series with the galvanometer here is such that this would then correspond to a potential difference across the leads here in red and black. That would then correspond to 10 volts. Okay, now I'm going to go ahead and switch resistors. Like so. This is still a voltmeter, but now the full-scale deflection current will occur such that then the potential difference across the leads is only 2.5 volts. So in order for that to happen, what I did is I changed resistors. So I have a different value of resistance now in series with the galvanometer. Okay, now let me go ahead and turn this into an ammeter. So when I turn this into an ammeter now, basically what I have done here is I've placed a shunt resistor in parallel with the galvanometer. The shunt resistance is extremely small, such that I can now read low amounts of current. In this particular case, a full-scale deflection will occur at 5 milliamps. So when 5 milliamps are passing through then the ammeter, this then means that the full-scale deflection current occurs for the galvanometer, and the needle then swings all the way over to the right-hand side. And then by changing shunt resistors like so, I can then change the maximum value of the current that could be read through the galvanometer. Okay, next, right over here is an electric motor. Unfortunately, this electric motor is broken, so I'm not going to show you this one in too much detail here. But off to the side here and here are the permanent magnets. This right here is the armature, and you can see the amount of coil of wire that is wrapped around it is quite large. And then the brushes are up here and here, such that when this thing does rotate, it's ultimately maintaining electrical contact then twice per rotation. As I said, however, this particular electric motor is broken, so I'm not going to use it. Instead, I'm going to use this little guy here that you've seen before, this guy like so. If you look down into the white casing there, you can see a little bit of those yellow wires. Those yellow wires that you see there are the brushes, and then the casing itself is the permanent magnet, and then we have the coil of wire here, as you can see, in copper or gold. And then I'm going to go ahead and then pass a small amount of current here through it by means of my transformer. That's my potential difference. Like so, and then therefore we can transfer then the magnetic potential energy. It then becomes useful as rotational kinetic energy, like so. Okay.